Alright everyone, this is going to be example 2 from section 8.3 in the note-taking guide. I was okay with this example, so let's go through this one together. This was y equals x squared minus 9 over x squared minus 4. So if we start with that rational function, we have a list of things to look for. We want to look for the horizontal asymptote, the vertical asymptote. Also want to pay attention to the x-intercept, if they have any x-intercepts, possibly more than one. And then we'll make a table of values. Not sure how many we need yet, but we'll check that out. So, horizontal asymptotes, we have those 3 tests. And we're looking at the degrees in the numerator and denominator. Since these are equal, when the degrees are equal, we're looking at taking the coefficients, which in this instance is 1, and we divide those, leaving us y equals 1 divided by 1, or y equals 1. So there's our horizontal asymptote. The vertical asymptote, that's what's going to make the denominator 0. So what helps us here is to actually factor as much as possible in the function. If we look, the numerator, x squared minus 9, is a difference of squares, so that's x plus 3 times x minus 3. And the denominator, x squared minus 4, is also a difference of squares and can be factored x plus 2, x minus 2. So for the vertical asymptote, if we're looking at the denominator, what makes those 0? We know that would be x equals negative 2, and that's x equals 2 for those 2 factors. So there are our vertical asymptotes. Now, the x-intercepts, we're looking at the numerator, what makes it 0, and since it's nice and factored, it's fairly easy to solve those as well. That would be x equals negative 3, and this one would be x equals 3. So those are our x-intercepts if we look at the points negative 3, 0, and 3, 0. All x-intercepts have a 0 coordinate for y. So then, let's just take this information, which is pretty helpful, and let's start looking at what the graph looks like. So make a fairly large one. We need a y-intercept of 1, so we need it to have more space up top than on the bottom, but not by much. So the blue lines over here will tell us all the markings, so we don't need to mark it if we're on graph paper. So we do know that this is the x-axis and that's the y-axis. So we have our horizontal asymptote at 1. So we're just going to draw a dotted line for that, labeling it y equals 1 to let everybody know. And then we have our vertical asymptotes at negative 2, and positive 2. Arrows letting everyone know they go on forever. Then if we look back, we also have our x-intercepts at negative 3, 0, and 3, 0. Now, cutting by these asymptotes, this point already tells us that it has to stay to the left of this asymptote and below this one. So this part of the graph must go right there. And you can't cross the vertical asymptote, so that's it. That part's done. And then the same over here, this is to the right and below that asymptote. So it has to run along that asymptote, hit this point, and then stay under that asymptote, giving us a complete graph there. The only thing we have to figure out is what's going on in between there. So like I said, we always pick a point to the left and to the right of the asymptote, but finding the x-intercepts already gave us that point to the left. So we only have to find the one to the right, which will be at -1. So we'll put that in there. We can also find one at 0, since it's always nice to find the y-intercept. And it's an easy calculation, you'll see. And then for this asymptote, we already found the point to the right, so we just need to find the one to the left. So that will be at +1. So then we'll calculate it at +1. So if we then substitute into our function with -1, and you have the option if you want to substitute it into the original or the factored form, your choice. I'm going to pick the original this time. So we would have -1 squared minus 9 over -1 squared minus 4. So that would be 1 minus 9 is -8, and 1 minus 4 is -3. So we're not going to do decimals, that's a little crazy. We'll keep it as fractions. Negative divided by negative is positive. 3 divides 8 twice, with a remainder of 2 out of 3. So then 0, you'll see 0 squared minus 9 over 0 squared minus 4, and that will result in -9 divided by -4. 4 divides 9 twice, with a remainder of 1 out of 4. So 2 down, 1 to go. Substituting in 1 squared minus 9 and 1 squared minus 4. And that will give us, oh, look at that, another -8 and a -3. Oh, because when you square a positive or a negative, you're going to get the same number. And that makes sense. So then that'll give us another 2 2/3 since it's the same. So now we just need to take these points and graph them over here. So it was -1 and 2 2/3. So that's 1, 2, and up about 2/3. And we had it at 1, 1, 2, and 2/3. So make sure it's about the same height. And then 0 was at 2 1/4. So we'll keep it as close to 1/4 as possible. And if you look, there's a nice little smiley face here. So that's what's going to happen. It's running along this vertical asymptote, going through these points with a nice curve, and then up along the neighboring asymptote. And then there's the completed graph.